Good morning, everyone. We will speak in English in this webinar because we have guests from Lithuania, Estonia. Kaspar, how is your speakers working?
Hello, everyone. So, can you hear me?
Yes.
Okay, good.
Runāsim angliski, ja? In 2 minutes we will start. Richard, Kaspar, I would like to share from our website a slide where we can see our branches and our locations and our telephones. I think let's start with this one, and then I will. But let's keep this one, yeah. Very, what I would like to say, a very, let's say, very deep winter at the moment. Outside is a lot of snow, and we find the right time to do some webinar because it's cold and solar constructions is not good in that cold weather to do. Let's wait for a couple minutes. Do we have a TIGO colleague connected? Kaspar, can you check?
Not yet.
Can you push him? Michal from TIGO will be Michal. He is originally Czech guy from Czech Republic. And Kaspars will present TNI. Let's wait one more minute and then we will start. Michal, hello.
Hey, thank you for
Latvian customers is very hungry of TIGO.
Oh, thank you. My apology. I had some technical issue to join this meeting. I don't know, something wrong on my side probably. So thank you for calling me.
Let's have maybe one more minute, and before some customers is coming, I will introduce myself. My name is Dirks Pākals. I'm a managing director of Baiva RE Solar Systems SIA in Latvia. Our central warehouse in Riga, Maskavas 495. We have around a little bit more than 2,000 square meters with a height of 15 meters and shelves is 14 meters. We have a quite spacey height and we can load a lot of goods. If I may ask Richard or Kaspar, share with me our locations in the Baltic from our website, please, before we start. And then I just want to show you from our website our locations. Please share it that we can see where we located in Estonia and where we located. Yes, this is our locations. As a first, you see Moscow Street 495 in Riga. This is our main central email, telephone. This is my name. Email start dirt.pakals and back is the same. Then we have Estonia. Can someone push also Melis? Melis is here. I didn't. Someone, Davids can call or Richard call Melis. He will join us. And he's the email, and he is a team leader in Estonia. We have office in Viru, Tartu, Manta 79A. Nice office. Anytime you are welcome in this office. And the Mantas is here also connecting. We have in Kaunas office. Team leader is Domantas Shimalunas. His email is here. Telephones, innovations tree. If you have Tesla, this is near Tesla supercharger. Always you can charge your car and go to Domantas office. What else I would like to tell you? This is fine. You can switch off their presentations. What else I would like to tell you? We completely changing price strategy from 1st of March. Maybe a little bit early will be more aggressive price strategy in our websites because it's completely rechanging what we have before. Because before we work different way, now we will change and calculate our prices from cost of the product, and each customer buying different quantities will have some smaller or bigger markup of the prices. Before we made different pricing. What else? We will extend very much product ranges in our. We will have at least 6 brands of inverters in stock, 3 brands of batteries in stock. We will be more aggressive with this constructions. We have signed a contract with Budmat. We have a price for 1 panel, and you can get a quotation just like this immediately. And today presentation is Michael from Czech Republic. He will make a quick, nice, not boring presentation about TIGO, because this is important how we can optimize our production. And Kaspars Prusis is our business developer, manager and team leader of batteries, all kind of residential, CNI, this is commercial purposes, and also utility scale. And Kaspars will present today commercial battery purposes of use and sizes and different kind of technical issues. And who is starting, Michal or Kaspars?
I would say that Michael could start with the optimization, and then we could use this optimized energy and store them in batteries.
And from my point that Kaspars will moderate, because in some 10 minutes I have to switch a different meeting, and Kaspars also there on end will be questions. And if you have any questions on online, you can just write it, or we will try to answer it. Okay. Michael,
yes, just a short note from my side. We do have a Q&A section present in Teams window. So if you have any questions, just write them in the Q&A section, and we will try to answer as good as we can. Yeah, thank you.
Thank you, Michael. Go ahead.
Okay. Hey, Gert, thank you. Thank you for introduction. Also to Kaspars. Welcome everybody on this short product show of TIGO products. As Gert said, my name is Michal Pavlicek. I'm working for the TIGO as a director of sales, and I would like to show you today a few hints about our product, not talking too much about the company, primarily about the product, and show you why the product may give you some additional value in the projects. TIGO company is a US company located in California. In fact, our company had been established in 2007, so we are pretty long time on the market. Worldwide, you may see the green leaves. We have delivered our optimizers, monitoring, and safeties for the solar power plants in all continents. In fact, we have delivered, already several millions of our products, which are full in operation and still supporting the features that we are delivering. As a company, primarily we have our optimizer, which is this box, which you typically install at the PV model. But slowly we are also entering a different segment. So if you will be interested in the future, we can also supply you with additional products like inverter with battery energy storage. And we are specialists for the software, which is our own product. And that is, I would say, the second part of the optimizer itself, because the optimizer is just hardware, while all the features which you are getting is in the software. The mission of our company is safety, energy yield, and operating cost, which is then reflected in the three functions that we are offering. So first, we will be talking about the optimization. Optimization is a feature that may increase the productivity of your solar power plants. So through a mechanism which I will explain in this presentation shortly, we are able to avoid losses in the power plants and improve the power generation. So we are also able to, reduce the aging of the power plants in time as well. But we are also able to help you to go over a different orientation, like west, east, and maybe north, three orientation in one, or maybe with some shadings from chimney or different elements. The second, very, very important, is safety. Safety on the PV plants becoming very important, especially for the commercial buildings and for the firemen and insurance companies. So safety is something that we will talk here about. And the last one is monitoring, which is here again about to reduce your operational cost, the service, but also to avoid energy losses, because you see a very high granularity of the system. So you may identify where you have problems, and also it can avoid losses due to the broken bypass diodes, or maybe a water leakage in the PV module that can be detected by these optimizers, and you get a message that at individual panel you have an issue, and I will show you how it works. In general, we have three products. The main product, which is the flagship, and we are strongly cooperating with company BayWa, also in your region. So you may buy immediately from the stock the TS4AO. That's the optimizer, which combines all the three functions in a single box. So you have the optimization, monitoring, and rapid shutdown control for the safety for the firemen in a single box. In case someone thinks that he needs just the safety, because maybe the budget is so short that the investor doesn't have enough money, or maybe the bank don't want to allow to slightly increase the budget. For those, we may offer, for instance, the TS4A2F, which is the most competitive solution and has only the safe functions for the rapid shutdown control, for the safe voltage at the PV level. And the 2F means that it's for two modules. So this is the most cost-effective solution. In middle, we have also the Model F, which is for a single module, or Model S, which combine the rapid shutdown control and monitoring, but the optimization is not there. So three products. It's important. What is the benefit for you to use it? For instance, you may see now on the screen the utility project which we constructed in Israel a few years ago, the 12 megawatt floating power plant. In fact, now last year we just finished a new 19 megawatt on the same concept, which is demonstrating that the model level power electronics is useful also for utility scale projects, not only residential and commercial, like people believe, but also utility. These floating power plants have its specifics, because whenever you would like to enter the ponton with the modules, which is on the water, you are always in the risk of getting injured by the electrical current. Why? Because of the high humidity, you are on the water, so it's always danger to go there when the power plant is in operation. Thanks to the feature, which is a rapid shutdown control, you can switch off the power plant. In fact, you can switch just segments, which you need to operate and do some services. And thanks to this function, you reduce the voltage to 0.6 volt at the individual modules. That allows you to go and enter the power plant safely, and to have in the strings also the voltage below 24 volts, so you can even touch wires with your hands. So safety it is. So that's, of course, and maybe extreme, but the same you may apply also on the commercial buildings, where maybe you need to do a service during the rainy days. You can activate it. Or maybe you would like to do a service of only single section of the project. So instead of 1 megawatt power to switch off to be in safe operation when you do service, you can, for instance, switch off just one segment, maybe 50 kilowatt. And if you would do a service of such project for 2 days, and you avoid switching off, let me say 950 kilowatt out of 1 megawatt, in fact, the 2 days out of operation will already pay all the investment that you have. So it's not costly, it's pretty cheap compared to the energy losses that it's avoiding. And typically the return of costs are very, very fast for these electronics. Second extreme, and we will go more deeply on this, is a residential business. A residential business which is typical with many different orientation of PV models because of houses are typically small, so there is not enough space, and some complex rooftops needs a lot of different orientations. Here, an extreme which is coming from Germany, where you have a north-south orientation, you have different models on the rooftop of the garage, and then you have one string which is connected east and west. Now, if you wouldn't use optimizers, this project is almost impossible to connect to single inverter, because you will have a significant losses. And moreover, these two strings you would never be able to connect because the voltage of two modules is not enough to start up the inverter. But by using optimizers, in such cases, you can connect it in one string. So one string having two different orientation. So you reach the sum of the voltage because you have four modules together. Let me say 4 times 40 is 160 volts. And when the sun is going over from east to west, the optimizers are automatically optimizing the current in all the modules. So even such complex projects, thanks to optimizers, you may connect to a single inverter, and in addition, it will improve the power generation, so it will avoid additional losses. Here, I was yesterday just creating this presentation for you. So I was taking from our monitoring system a real cases which we have, and only the one, in fact, which give us a permission. So here I am showing you a residential project which is located in Czech Republic, and we have two pictures. Both are coming from November 9. So it is not the summer, it's not the winter, it is November, so autumn, November 9 at 9:32 a.m. In the morning. You see the sun is coming from here, we'll go over. And we have here 4 different rooftops. In fact, this is a 1 string, and here we have a 2nd string and 3rd. Now, what you see on the left picture is the power of the PV module. So because it's a winter, it's autumn, it's November here. So the sun is very low. It's close to the length. So you may see that the power of the modules, even there, I think something around 350 or 400 watts. It's about 156 here, 200 watts. And the one which are in the shade are at the 34, 35 watts production, pretty small power. But if you look on the right picture, here we are showing the reclaimed power. So the power which in addition produce the optimizer. So you may here on those modules which are, oriented towards the sun. There is no need at this moment too much to optimize. Of course, some small needs are, but not big. While the modules on the backside are having all the power from optimization. So if the optimizers wouldn't be installed in these modules wouldn't produce any power because they will be oriented to the shade on the north side. So here, thanks to optimizers, even though it's a winter time, the sun is very low, the modules are oriented towards the north, and you can see it also on the shade on the picture, which is not a real picture from the November 9, but it's showing what is the south, what is the north. So you would see, thanks to optimizers, you could also get the power from these modules, which are far from the sunlight. The project is 10 kilowatt. In fact, is using also our inverters with energy storage, 12 kilowatt hours. So we will show also some features there. You may see if you look for the last 4 months, because the project had been started just in September. So it's only 4 months in operation. And in fact, if you calculate this light green, which is the additional power reclaimed from the optimizers, compared to the dark green, which is a power of modules without optimizers. So you may see from the numbers that the average reclaimed power from these 4 months is 12%. So thanks to the optimizers that are deployed on all modules, the project is producing 12% more power in average during the 4 months. If we would look to more details, and here we have also the battery curve and the consumption of the house. In fact, on the date November 9, which we have been showing the pictures before, the reclaimed power was 14.28%. So in fact, if you have at least light sunny day, even in winter time, it is giving you even more than 14% reclaimed power. If there is no optimizer, these 14% will be lost, while the optimizer is giving you this additional power. Now, if you think about investment, and let me say you count a return of investment of your project 10 years, if you get 14% additional power from optimizers at these kind of residential projects, it means that instead of 10 years, the project will be paid 1.5 years earlier, so 8 years and a half. That's a massive reduction for the investor. It's strong improvement. Yeah. It produces more energy, it faster return of investment, and in addition, still you have the monitoring that I will show you soon, and you have the safety on the roof. If we would come to commercial rooftops, in commercial rooftops, and modules are typically more, more flat, more oriented to the south, typically, or west-east. There are not so many different orientations, typically. But very often on the rooftops, you have kind of small walls which are putting shades on the models. Maybe an elevator room which is putting a shade. Maybe air condition. You know, you have an industrial house. They have a lot of industrial, air condition systems and cleaning systems on the roof, which are putting a shade on the models. And maybe not in the summer, but surely in the spring, autumn, and winter time. In such cases, these PV models, which are in the shade, are losing power, losing a current. So what's happening is that in these modules, instead of having a current, let me say 12 amps, in those modules, the current is maybe just 6. And that is causing that the module with the lowest current in the string is defining the power of the string. So if one module will be in the shade, or will be dirty, or will be having some technical problems, in such case, the power of that string will be reduced due to that one single module. The optimizers have the function to increase the current. So as long as they can, they are increasing current of the individual modules, the current that the inverter wants to be at the maximum efficiency. How is it doing that? What he do is that optimizer is a passive component that is measuring the impedance of MPP tracker at the inverter, and based on the impedance, he calculates the current which the inverter wants, because that's the flow, the current he wants, and comparing it to every of these modules. If the module is perfect, like this one, he stays in standby mode. If he see any shadings or dirtiness on the module, so the reduced current, what he do? He take the power of one module, he increase the current to the one of the best modules to do not cause any losses, and slightly reduce the voltage. So increase current, reduce voltage from the square of the same power. Through that, you may increase the productivity of every string because you are avoiding the natural losses which are happening on every module. Now, the shade is one of the extreme. Of course, if you look on the list of your PV modules on the flash test, typically you see every module has slightly different current. The optimizer is able to align also those currents on every module. So even though you are in the string of perfect modules on the day one, optimizers are able to optimize even that small differences of currents and improve the power generation. So it works anytime at every module, and it's always improving the power generation to avoid the losses. Now, if you think about day one, typically projects are perfect. But if you think about 1 year operation or 10 years operation, a natural degradation of PV modules is coming. Even PV module manufacturers showing the degradation curves. Those degradations can be partially improved by the optimizers. So if you would deploy optimizer retrospectively on, let me say, 6 years old power plant, probably you will see an improvement of 10% production. Real cases again. This is a project from ERP in Netherlands. This is a project which is on commercial building for the agriculture. You see there is a south orientation and north orientation. Yeah, south and north. So theoretically, you don't have here the troubles of the shadings because there is no chimney. I don't see any wire here. Of course, this north power plant produced less than the south one. And even though it looks perfect, you may see that on our monitoring, if you scroll out to zoom out, you may see that this module is a dark green between the light green models. Very easily, just on the first look, when you look, for instance, on this is pictures from October 14 at 11:17, you may see that module may require some small inspection online. Now the module is somewhere here, so you may see there's a sunny, there is no shade, nothing. So the module must produce maximum. So the question is, why the module, instead of that moment, because it was probably cloudy or rainy, I don't know, instead of standard 153, 151, 149 watt peak, is producing only 55. The question is why? And this is exactly the moment which is giving you a chance that you may go and check the voltage and the current online if you have the premium account with our system, so you can online detect whether the problem is on the module or on the string or where. Or it can also tell you, look, this module, and this is what is probably the problem, is probably having a lot of micro cracks in the cells, which are causing a big energy losses, or maybe the glass is broken. So very simply online, when you see such a model and this, you can already have maybe 3-4 scenarios which are very probable. What is the root cause of this issue? So you can inform the investor and you can say, look, if you like, we go and we repair this module at certain cost, or if you like, you can leave it until it's only one module, it's still fun maybe for you, with your decision. You have a very, very great inspection tool. I also took 2 different days because this was on October 14. You may see that on July 18 at 11:17, the model was still fine, was the same power in watt peak, while somewhere in September, and I took here the September 6th, the same time to have the, I would say, similar comparison, even though probably light was a bit different. You see the power is slightly lower here. Well, you see the broken module has significantly low power already. So instead of 335 watt, which should be the maximum power of that module, probably in some colder weather, has only 22. So you can even identify when it happened. If there are kind of these degradations, which are micro cracks or broken glasses or those, you may also sometimes receive some error messages automatically. But for sure, the optimizer is giving you a message that there is a broken bypass diode. So if, for instance, the PV module is losing 30% power, you immediately get a message which is showing you which module has an issue. This is an excellent tool because you may do an additional services to your clients, and the end customers have a great tool to see if they have some troubles. And what's very important with this measurement, because we have hard data for every day, you can take it, and if it's a problem of module, you can get the warranty. That's important because you can go to your module provider, give them these measurements, and you immediately get a warranty. Or maybe a bank, investment bank, is looking for that because they would like to be sure that they are having this feature to detect a broken module. Now, here in this case was just one. But if we go to next case, and this is a 56 kilowatt project, I think it's in Italy, in Alto Adige. I will write it somewhere. And you may see there are, again, different orientations. Yeah. 1, 2, 3, 4 roofs. So 4 different roofs, or in fact 6. And you have a big, probably for some agriculture product, which is causing a big shade. It's again a great case for optimization because you may see the last 6 years, if you look, the average reclaimed power is in average in 6 years more than 10%. And I'm talking about average, I'm not talking about some extremes. So it's a demonstration of 10% additional power in the period of 6 years. Now, it could be probably higher production, but the trouble is, and this is what we are talking to customer, that they have 3 modules which are having technical problems. So it looks like in the past, nobody cared about it. Now they are already repairing it. But just from the single look, and this is, for instance, on January 6th, and I'm sorry, this year, forgot to change this number to 24 at 10, so it's like 2 weeks old. You may see that from first look, 1, 2, and 3 modules have 0. So surely there is a technical problem. You can immediately go on site and repair it. If you look and there's a simple comparison between the power, you see immediately you have an issue. Of course, there might be some extreme shade. So you can also say, okay, maybe this is not happening. Maybe if I go to 11, it will disappear, but unfortunately not. To repair those modules, then of course, immediately you get probably 30% more power in that strings. The troubleshooting, can be very wide. It's a lot of issues. It could be a current, which is different. It could be micro cracks in the cells. It could be a water leakage in the PV models. Sometimes happening that on the module you have a delamination process, which causing that a humidity is going in the module, and when a cold weather is coming, it condensates, and it's causing that the power is then leaking to the ground. This can be detected by optimizer, and you get an error message on email. Same with the bypass diode. If in the IP box, one bypass diode is broken, you get an alert. The bypass diode is broken because 30% of power is out. But it also improves small things like a dirty PV models. I'm not sure if you saw it, but if you have a PV model on the roof, say 1 year, on the bottom, where is the frame, there's a small place where is a lot of dust and causing a shade to the cells. It can be also optimized. A shade from the chimney. It can be also a shade from, a wire of the grounding inductor, the lightning inductor. So very small shade going around, but causing maybe a losses of 5–10% on the project. Again, can be optimized. Or maybe the project is below the windmills, the big windmills that are turning and producing energy and putting a shade on the models. Again, can be optimized. Or because Baltic, I believe, is typical that clouds from the sea are going over their country, small clouds, very fast. So these small cloud shades can be optimized, and we can improve the productivity of the power plants. To this, you have a complete software free of charge. So you see the productivity of the models, the additional production of the optimizers. You always have the online monitoring for the weather, or you can connect there the meteor station. You can connect also inverters to see how much you get from inverters. For the investors, you also show how many trees, how many kilometers, how many fuel, and how much CO2 you save. You have the daily production. You have it also as an app for your mobile phone. And of course, we have all the charts that are helping you to investigate where maybe you have an issue. You have also alerts. So you are getting alerts. And for installers, we have even above a fleet management, so you can have all projects at a single screen. When you do and screening of the project on You can do it free of charge by hour, day, month, and year, or you can buy a premium account to have it also by minute. So this is the minute screen. You see it's very, very complex. You have a lot of data to study, and also showing you a lot of things. In fact, this is it looks like this because this house, and I will make it a bit larger, is made of 3 different roofs. So it's a east, west, and south, where the upper modules are 1 string and the bottom modules are a 2nd string. So you have the minutes, you have the hours, days, months, and years. Yeah, this is also a real case. If we would look on the production here, so for instance, at such project, we have 39.97. So you have a 25% additional power reclaimed from the project. But if you wouldn't have optimizers there, you would lose 25% of power. It's amazing. It works. You can also have these kind of, checking. Let me just stop it to make it larger when it's running, so you see it well. So you may see when the time is running, you can do the study of the PV models when the sun is going over from the east to the west. You may see the south string is not optimizing too much because it's oriented just to the south, while the east-west string is optimizing a lot. The power you see is the optimized power, the reclaimed power. And you may see how it's optimizing each model. You can also see there is a small satellite on the roof, on the top, which is creating a shade onto one model. So on such roofs, the optimization is really doing miracles in case improving the power generation. All this data you have then for your use, also your end customers, if you allow them. So you may study maybe quarterly or half a year. You can do a short revision if everything is fine or not. An excellent tool it is, especially if a customer is saying, look, I have a feeling that my project is not producing enough. So he is putting on you a warranty for the project that, for instance, instead of 1 megawatt hour per year, he produces only 800 kilowatt hour per year. In such case, you can look in the 1 year history. You can say, guys, look, we exactly know where is the issue because, for instance, there has been broken a bypass diodes, which causing the losses. Unfortunately, nobody saw it before. So we repair it and it's a consumable, so there is no warranty. Or you may also see, look, the weather and the conditions which had been during the last year, unfortunately, due to the weather conditions, caused that there was a maximum 800 kilowatt hour production, and the one that will be maybe the year after when the weather will improve. So all these can be online, detected from your office with drinking a coffee. So again, all these features, optimization, monitoring, and rapid shutdown control can be purchased in the single product TS4AO, which is in stock at BayWa, so you can buy it anytime. If you would need, we can also supply you with the only rapid shutdown control or the combination of rapid shutdown control and monitoring. For the installation, just fastly, typically you install the optimizer on the frame of the PV module. So there are metallic clips where you take just the optimizer, put it on. Once it's fixed, you connect the cables of the PV module to the short strings, the short cables. So first you connect the module to the optimizer. Once it's connected, you remove here a QR code, which you use then for monitoring. And then when you install it on the roof, you connect it between each other. That's it. No additional material is needed. Everything is included. Only if you would have the frameless PV modules, so-called glass, where there is no frame. In such case, you can remove these metallic clips, and inside is a whole M8, so you can then screw it on the mounting system. Very easy. Standard model, which is currently in production and available, is for PV models up to 700 watt peak power and up to the current 15 amps IMP. There's a 15 amps IMP. The short circuit is up to 20 amps, so no worry. For the monitoring, to have all the functions and to have full warranty, you need also the CCA and tab. So CCA and tab for monitoring, I will show you shortly as well. Just in case you would take the S, it's the same parameters, 700 watt and 15 amps. You need CCA and tab. If you would go with the F, the rapid shutdown control, let me maybe speak about the 2F. We have two models. We have a 15 amps or 25 amps. So if you have a big bifacial modules or very large utility scales modules, which are maybe 18 amps, you can take the high 25 amps fire safety protection, and with the power up to 1,400 watt. So then you can decide if you take the cheaper 15 amps 1,000 watt or the more expensive 25 amps 1,400 watt. In fact, price difference very small. I'm saying more expensive, but it's just like €2. Nothing crazy. For the correct functionality, you need the RSS transmitter. RSS transmitter looks like this. This is the unit which is sending a signal to the rapid shutdown control to control the safety. You see also a large rooftops we do with this technology. So with O, the optimizer, you need the tab and CCA as a complete. For the rapid shutdown TS4 A to F, you need this one and the RSS transmitter. Now, for you as the installer, or maybe even an owner of several power plants, we are offering fleet management, which is a software above standard monitoring. It's free of charge at this moment. So you may see then all the projects which you installed at the same page, also with the graphics. So you also see the status of every project. You have a complete portfolio. So for instance, every morning at 10 o'clock, if you just open the screen for maybe 10 minutes, you immediately see if all projects are working well, or if one project has something to check. Very easy, everything online. When it comes to the monitoring itself, to get the data there, so as said, we need the tab and the CCA. So typically on the modules where you have more optimizers, you have typically one optimizer per module. You also need a tab, which is the TIGO access point and the wireless monitoring of those optimizers. Typically, you need one for up to 150 optimizers, depending on the complexity of the roof. Yeah, if it's super complex, so it's different orientation, you probably need more tabs. But if it's an open, free landscape installation in utility segment, a one tab for 150 optimizers would work as well. You typically connect it through RS485 cable to the CCA cloud data logger, and the data logger is then sending the data through Wi-Fi, the modem, or through Ethernet to the modem to internet. The data logger CCA has the connection gateway for the tabs. You can connect up to 7 tabs here. It has also the power supply. It has the AUX for controlling the rapid shutdown control for the service purpose. And you can connect also the monitoring of inverter and the monitoring of meteor station if it's in the database. If it's not in the database, you can ask us to edit. Unfortunately, it takes some time, but it's possible to also add new devices. to monitor. When you are on typical small residential rooftop, like this one, for instance, you would put probably the tap somewhere here in the corner to be able to monitor all these optimizers. In case there is some barrier which is maybe avoiding to see the last optimizer, we can ask our technical support to set a different frequency, or you potentially just move it maybe one model right to also catch the signal here. Then you go with this cable to CCA and you have the data already on the monitoring. Very intuitive, very easy. You have one single app in your mobile phone where you can commission everything and set. For rapid shutdown control, you have two choices. One choice, and this is what is now shown on the picture, is to connect a switch or whatever contactor to the aux port. You can even connect, because if you have a big project and you have more CCAs, you can connect them all in parallel, or you can connect one button to each to be able to switch off each individual CCA individually. If you touch this button and you connect the relay in this CCA unit, it automatically brings optimizers and rapid shutdown control in the safe mode. That means that each box will reduce the voltage to 0.6 volt. The 0.6 volt is a control voltage. So if you have 10 optimizers and you will check the voltage in the string when it's closed, there should be a 6 volt in such case, 10 by 0.6. So we can control everything is working well and there's no issue. That is a great feature for service. So for instance, you want to go on the roof, you would like to check the cables, maybe you would like to do some cleaning of the PV module. So what do? You click this button, just click, it automatically switch off. So you can go on the roof, you can even touch cables, you can put a finger inside if you prefer, but I still don't recommend it. Because the voltage is below 24 volts, so you can even touch it. And such case is excellent because you can just disconnect and connect the power plant in very easy mode. And you also see it on the monitoring. When you touch it, you also can check on monitoring, it's really switched off and you still see the monitoring. You are not losing monitoring. So you know that this is under operation or under service. The same can be used also by maybe a person who is going to repair an air conditioning unit on the commercial roof. So he needs to maybe change the filters in the air conditioning system where is a power plant. So he shouldn't enter until it's switched on. So by this single button you can touch, you can just around the air conditioning system to switch that block. You can go clean the filters and go back, while the rest of the project continue in production. So you are limiting production only on very small place and avoiding energy losses during services and operations of different units, or maybe you need to, repair an isolation on the roof. So the same case. If it would come to the firemen would maybe disagree with this button because they prefer that the button is not to switch on, but to switch off, so to cut the cable. While here, if you switch on, and of course, if the cable would be broken, nothing would be activated. Such case, for firemen, the CCA is typically connected to the main switch of the house. So when they put down the main switch of the house, CCA lose the voltage and immediately everything's go to rapid shutdown, everything without any compromise. If you would be even better than this, you can add one additional red button to the power supply. So and the firemen put down the main switch, there is a red button to push to lose the power. Immediately everything's going to rapid shutdown. When I say immediately, the norm, and we are following the UL, which is the most strong and most strict norms, is saying that it must happen in 30 seconds. Now, rapid shutdown is even faster, but the 30 seconds are there because there is still a voltage in the capacitors of the inverter, which can go reverse. So for the safety reasons, the norm's saying 30 seconds. So 2 cases, for the service, for the firemen. Everything is available. When it comes to the tap, so the wireless device, which is monitoring and controlling the optimizers, you typically go with the RS485 cable from the CCA and you connect inside a terminal, inside a tap. It has again the clips, so you can just put it on the frame of the one module. I would say you typically use 1 per 50 optimizers or even more, depending on the project. But if you have maybe a one roof, which is on one house, and the second roof on the second house, or is big one, you can also go in series and connect the taps in a serial connection. So you go from CCA to the one tap, and from here you go to the another tap. It's possible. The only would you need to have the terminating resistor in the last tap to terminate the communication. It's always included inside. So you just remove it when you continue and leave it there when it's the last one. Very simple, no troubles typically. When it comes to the length of the cable, of course, there are certain limits, but as we have the cable length up to 9 millimeters, so up to 9 millimeter diameter can be the cable. We can have pretty thick communication cables, and as you may see, we can go even with one tap up to 793 meters with standard AVG cable, or if you go with the more robust cable like Cat 5.6, you can go even to 1.2 kilometer long cables. Yeah. The limitation is here because of the voltage drop. Yeah. That's like in standard communication, so nothing specific. If you would have such cases on the rooftops, if there is a barrier, unfortunately, some kind of barriers do not allow the wireless communication to go through. So then maybe you would need 2 taps here. Same if on the rooftop, the distance between 2 strings or 2 optimizers is longer than 10 meters, more than 10 meters from each other, again, 2 taps are needed. If, for instance, here would be another project, other models, which have been only 3 meters distance, you don't need it because optimizer works as a repeater. So that optimizer will repeat the signal to the next one as long as they are closer than 10 meters to each other. A very robust and easy solution. When it comes to an 2F module, so the rapid shutdown control only, as I said, for that rapid shutdown control only, so the TS4A2F, you would need an RSS transmitter with inductive coils. That's the only change. Yeah, where there we had CCA and tap. TS4A2F, we have RSS transmitter. How it works? You typically put the RSS transmitter with coils close to the inverter on the negative wire. Transmitter is generating a signal and sending the signal through the cable to all the rapid shutdown controllers. Very easy, very robust solution. No wires and no Wi-Fi or nothing. Simply just a signal through the DC cable. The only limitations you have here is the length of the wire of the complete string. So from the minus to the plus. If you have one coil, so if you have one coil like this on the cable, the maximum length is 300 meters. If you have 2 coils like here, let me zoom it so you also see. And if you have 2 coils like here, next to each other, you extend the length of the cable up to 500 meters. 500 meters means that the string will be like 230 meters, 270 meters, the complete string, because you need to count that some bars have some curves as well. Typically, you go through the coil. It's not openable, so you must go through before you put before you clamp the MC4 connectors on the cables. So you go through the coil. Typically, you put up to 7 cables. Maximum is 10. But typically, you go with like 6, 7 cables if you have like, let me say, 50 kilowatt inverters. Always the white cover shall be oriented to the inverter, the black one to the modules. And what is very great too is that when you have more inverters, so you have a big project where you have more inverters, more RS plus transmitters, where each is sending the signal. So to avoid that the signal could be lost due to the crosstalk mitigation in the channels where we have the cables, we have patented a solution of synchronizing the transmitters. So you can connect up to 10 transmitters together to synchronize them. And then it's causing that the first one, which is on the first line, then working as the master, the rest of the leaders, and then it's sending the signal in one moment, which is then able to operate even very super large projects like you see this one in US. So even the very large projects can be operated with this very, very simple and robust solution. In fact, in US, this is the main product because in US, every project must have rapid shutdown control. There is no excuse. In US, every project must have rapid shutdown control. In fact, in Europe, it's starting. If you look in Slovenia, Austria, Czech Republic, Germany, now Romania and Slovakia coming, all those countries are mandatory asking for rapid shutdown control at the commercial buildings. There's no excuse anymore. Insurance are penalizing if you don't have it in these countries. Probably may happen in your countries, may happen similar. So if you have a factory which is insured, then maybe a client or insurance companies will ask you to have such kind of rapid shutdown control. So you can decide that if you want to have a full optimizer, which is the perfect tool, which is also earning money. So it's shortening return of investment, it's producing more energy, it's do not require so much, DC-AC overloading of inverters as well, so we can save some money, and combining with monitoring and rapid shutdown control. All things in one house. Just if you would like, TIGO has also inverter with power management and batteries, but this is a different topic which I'm not going to talk here now. If we come back to the products, the optimizers, let me come back here. So optimizer has a 25 years warranty. So the optimizer has 25 years warranty when it's connected with monitoring. So if you use a complete system, including monitoring, you have a 25 years warranty on the optimizers. Monitoring devices has 5 years warranty. When it comes to rapid shutdown control, the unit has a 25 years warranty always. A transmitter has a warranty 10 years. So also very long warranties. I would say it's probably all from me today. I would maybe now give a speech also to Kasper, who would like to show you something. And of course, I believe there are maybe some questions. So we may go to the questions later on or now as you prefer. Kasper, yes. The word is yours.
Yes, thank you, Mikael, for your presentation. I believe that we can have some questions now as well, so people don't get lost after the battery presentation. There is one question in the chat, which asks whether there are plans to produce panels with built-in optimizer in the future. Actually, very good question. Michael,
Look,
what's your...
TIGO already worked in the past with module manufacturers. So there had been a few, especially in China, who deployed our optimizers and inside the package of the module. But I think after 2 years, they decided to go out because they said that for them as a module manufacturer, due to the additional cost of electronics, they become less competitive in the market when comparing to different modules. So their strategy was later to keep it separately. But there are, for instance, Jinko, which is very closely operating with us. We even have a model with the Jinko connectors. So that is super compatible. But we have also connectors with Stoibli, MC4, EVO2. So we have for 1000 and 1500 volt. But I guess, and that's my guess, 15 years in photovoltaic, that probably modules will still keep it separately to show the most competitive price of the PV modules and not combine with some electronics.
Thank you. Maybe some other people have thoughts on this topic. Or no, any
Maybe
other questions?
I forgot to say one important detail. The optimizer, because I said it, check the impedance of MPP tracker. The unique point of our optimizer is that it is compatible to any inverter that has MPPT and is on grid. It's compatible, I would say, to all inverters on the market. I think the only 2 exceptions today, which I know, is Solar Edge, because it's a different product. They work on different because they have a micro inverter, which is then connected to inverter, but they tell you how it works. And the second is Victron, which is not optimal because Victron is using on the DC side a DC-DC inverter to charge the batteries, and then the AC inverter is going from battery. So here, unfortunately, it doesn't work correctly. You can work with F, with rapid shutdown control. You can work with monitoring, but not the optimizer. Yeah? Mm-hmm. But except these 2 brands, the optimizer should be, I'm saying should be, compatible to any on-grid inverter that has MPPT. And doesn't matter if it's string or central. It works also with central inverters.
Just a question regarding Huawei. Is it compatible with Huawei inverters as well? Because they have their own.
Yeah, we're often supplying Huawei with our technology. Yeah. Also, especially the bigger inverters, because they don't have even a solution, but also smaller projects are very often supplied with our optimizers. I have a feeling we have even slightly better cost, but for sure we have some functions which nobody have. Yeah, if you look on inside the monitoring software of TIGO, it's one of the best monitoring which you can today buy from any company in terms of data, data storing and data mining from the system is very fast. It's nearly online. Yeah, there is some small delay, but it's nearly online. Very robust.
Yeah. Actually, one note from my side: when you calculated the improvements of the optimizers, you actually did them wrong, because you should have divided the gains with the power that you could get without them, and then the improvement is even larger. So I calculated it's 23. For some it was 30% improvement. So this seems to be very promising and really good figure to show to the clients.
True. So, yeah. Go to that deep, yes.
Yes, exactly. Okay. So any other questions? Maybe you can even write them in Latvian in chat and I can translate. Lithuanian I won't be able to do, or Estonian. So anything else you would like to ask Mikal while you have this wonderful chance?
I would say if maybe nobody has questions and still BayWa remain the first contact for you in your region, like maybe some later technical problem or anything may happen, you also have here my email, so you can write directly to me, or we have a technical support online that you can contact via the web form or phone. So if you have a design challenge, you would like to help with design, if you would like to help with maybe commissioning, or maybe there will be a need for training, you can contact us. Same, we have also a TIGO Academy online. So if you go through the presentation, a short one typically, and you finish the test, you get a certificate of TIGO. So you can get also to your customer and say, look, I passed the training of TIGO. I'm certified partner. So I'm entitled to install and operate the units. All the support today is generally online. I would say 99% cases which are coming are manageable also online. So a lot of things which we can see on the monitoring are helping us to immediately tell you where is the technical problem and to help you even at site. So we will try to reply as soon as possible within 1-2 days to do not cause any energy losses or time losses. Okay, if unless there is some question, probably give the time to Kaspar because he would like to show you an additional very interesting product. So I think it will be good to stay.
Okay, yeah, thanks, Mikael, for the presentation. And so do you see my screen?
Yes.
Okay. So my name is Kaspar. I was introduced by Gibbs, but we're going to do that one more time. So I'm business development manager here at BayWa RE Solar Systems, and my main focus now is energy storage systems from residential to CNI and utility as well. So broad spectrum of battery-related solutions. In this presentation, though, I'm going to focus more on CNI solutions, but for those Lithuanian colleagues who visited our seminar in Vilnius, this presentation will have multiple things that were presented and are similar for both CNI and utility scale projects. So let's begin. And agenda. So I'm going to give a small overview of BESS, ESS or BESS system, then provide some application scenarios. Then we're going to move to parameters that are important for ESS systems. And then let's move to solutions that we offer, as well as, if the time permits, experience that BayWa RE has in battery storage solutions. So for introduction, so BESS is a short term of battery energy storage system. In internet and in other sources, it's also called ESS, so energy storage system, and it's a type of storage that uses batteries to store energy in form of electricity. So it's one of the subsets of energy storage systems because there are alternatives. For example, hydro, air storage, flywheels, nuclear as well. But in this presentation, we'll focus on CNI battery energy storage solutions. And here on this slide, you can see two typical CNI products. On the left, you could see a battery product for indoor use, and on the right, you could see a battery product for outdoor use. On the left, it's SMA solution, and on the right, it is Huawei solution. And if we talk about batteries, then we must understand why to use battery energy storage system compared to alternatives. So first of all, they have zero emissions because they do not emit anything in the atmosphere. They are relatively light and compact. So, for example, you can put 20 kilowatt hours package in enclosure that weighs 130 kilos with small dimensions, as you can see there. They have high energy density. Also, a very good factor is low maintenance. You have to service them sometimes even yearly or bi-yearly, so lower operation costs. They have long lifetime. If they are operated properly, you can reach 10 plus years of service life. Another very good feature of them is that they can be charged or discharged really fast. And this is good, especially for high power demanding applications, like example, grid balancing, which we'll talk about later. They have relatively low self-discharge compared to other battery types, and also they are very modular. So you can put them starting from one module, and you can scale them and put them into 10, 20, 40 feet container solutions, which are more for utility scale, but it's worth mentioning. For now, there are two main battery technologies used in CNI and utility products, also residential. So those are lithium ion, which is lithium, magnesium, cadmium batteries. So shortly, Li-ion batteries. And the second technology, which is newer, is lithium iron phosphate battery. And here is a small comparison. So LFP batteries are a little bit more expensive. So this price is per cell, not for the module. So these LFP batteries are a little bit more expensive. They are not, as a newer technology, not as energy dense as lithium ion batteries. They weigh a bit more, so this is maybe not that great feature, as we have to, in Latvia, pay for battery green tax per weight. But where LFP batteries really stand out, first of all, and that's especially useful for our climate, is temperature range, because they can work from temperatures to -20, from -20 to up to 60 degrees, compared to Li-ion batteries, which work best from 0 to 45 degrees. Also, LFPs have really good charge and discharge ratio, especially discharge ratio or power. So we are going to talk a little bit later about what these C ratings are, but for comparison, they can discharge 25 times faster than lithium-ion batteries, which is also a very important factor if we talk about grid stabilization, grid balancing applications. Also, LFP batteries do have longer lifespan, which is measured in cycles, and one cycle is full charge or discharge, with a note, of course, that if properly charged or discharged, and we're going to talk about it in the slides following this. And also, a good feature of LFP batteries is that you can discharge them up to 100%, while lithium ion you can discharge from 80 to 95%. And also one very good feature of LFPs compared to lithium-ion batteries is that they have a lot lower risk of thermal runaway. So for lithium-ion batteries, they, in simple words, when the temperature increases, there's a really high possibility that those batteries are going to burn and cause thermal runaway to the different batteries as well. But for LFP, this temperature threshold is higher, meaning that there is lower risk of fires. And for this reason, LFP technology now, I would say, is the main battery technology used in storage systems. And not only storage systems, also in EVs, electrical vehicles. And if we are talking about C&I battery storage, so we must understand that this solution does not consist only of battery itself. It consists of multiple elements, and on this slide you can see an example from Huawei ESS system, and you see that it consists of cabinets, of PCS or the inverter, or also on HVAC systems, then on controllers for the battery racks, also such features as emergency shutdown switches, then of course the battery pack themselves, distribution box for the connections. Also, this system consists of fire extinguishing system in case we have such kind of event. So the fire or thermal runaway could be avoided, not avoided, but this fire hazards could be lowered. And also we have multiple sensors, for example, temperature, humidity sensors, smoke detectors, CO2 sensors. Also for this particular system, we have such thing as exhaust system, which means that in the case where you have issues with the batteries and they start to produce gases, these gases can be released outside in the atmosphere, reducing the possibility of fire being present in this battery storage. And of course, there's water sensor. So by this, I wanted to emphasize that these systems are complex, consisting of multiple elements, and each of these elements has a specific role in the good operation of such a system. And now let's talk about one of the main reasons why we would use these kind of battery storage solutions. So one of the drivers, of course, for thinking about adding storage and PV as well and other renewables is the increasing electricity prices. So here's an image from Public Utilities Commission of Latvia, and these are Latvian residential and commercial client prices. And as we can see, starting from 2021, the prices comparatively have increased almost 3 times. And this price trend will probably be increasing as well in the future for the electricity prices, because there's inflation and other associated elements that constitute to this electricity price increase. So one factor is price increase that affects our willingness to add these systems. And another factor that makes these systems more attractive is the changing electricity prices in the 24-hour period, which means, for example, that the price in the morning could be higher, in the midday lower, in the evening higher, and at the night lower as well. And on this slide, you can see Nord Pool spot prices for Latvia for the past week, including this day. And on this small table below, we can see the minimum price, maximum price, and the difference between max and min, so the delta price. And these electricity price differences between, let's call them peaks and valleys, is a factor that by using batteries we can use on our advantage. And on this slide, I want to show a couple of business models or use cases for using CNI batteries, also utility batteries in that regard. So this particular image is taken from Huawei. They had really good presentation where they showcased the business applications, and I will on this slide just to mention them, and further we will explain each of those. So first of all, first application is self-consumption. Then we have grid reinforce, also such thing as peak shaving. Then we have time of use application, or peak valley arbitrage, if that's familiar term for a lot of you guys. Then there is also frequency regulation or grid auxiliary services, which I already mentioned, and of course on or off grid backup mode. So first of these applications is the one I think that's very that's reasonable for our market, and that's maximum self-consumption, which means that if for example, if we combine this battery energy storage system with PV system, we can use power generated during the day, but not used during that time, and store them in the batteries, and to use that energy, for example, later when we have energy demands or when the electricity price in the grid is higher, and it's more reasonable for us to use the energy that we have stored. So on this slide, I just want to mention that, of course, the best return on investment is when you combine these energy storage systems with PV. It's when we use this for maximum self-consumption for commercial clients. And it is really important to understand your energy requirements, because not always bigger battery is better when we look from the return on investment perspective. And here on this table, we can see one of the examples given that depending on different solution that we use, our return on investment can change as well. So if we want to have these solutions for our clients, it's really important to understand what exactly are their energy demands, so that we can provide the best solution from the capacity perspective. Other application that is also relevant, and I believe that it will be more relevant for our countries, is grid reinforce. And by this, we mean that example would be EV chargers. So if we want to add EV chargers anywhere in our distribution grid, we usually will have to ask reconstruction of this grid, so that we can add these high output power charging stations, which means that there needs to be probably some more powerful distribution transformer, distribution boxes, etc. And that's very expensive if we have to request it from the grid distribution operator. And it's very time consuming, but this can be avoided if, for example, we use the same existing grid with the existing power outputs and combine it with energy storage system like a battery, which we can use to store energy, which we can use to charge them at nights with this low power output from the grid. And during the days, we can use energy in the batteries to provide high output power to charge the batteries. So that's one of the examples that we can have. Yes, I believe that's about it for this slide. The next application that's probably not so important for us is demand management. So for example, on different European and other countries, you have an additional demand cost for power requirements that exceed certain limits. And you can use these solutions just to do demand shifting, which means that you can add these batteries and charge them from the grid. And when you need this high output power that you would, in other cases, would have to use this demand increase costs, you would use energy from the grid and from the battery, thus avoiding these demand charges. And also, this might be the case where you have existing grid connection with power limitations, and you can add this battery to augment it and to provide higher output power during your peak consumption times. The other application, which is, I think, will be one of the most important ones here in Baltic states as well, is time of use or peak valley arbitrage, which basically means that we charge the battery when the electricity price is low, and sell the energy stored in the batteries to the grid when the electricity price is high, and then we earn from the difference between this price. Also, an application that's important, especially for utility scale projects and for utility for solar PV or wind PV plant owners. And I've even written that it will be necessary to add battery storage systems for such solutions, because in the previous years, we have a rapid increase in utility wind and especially solar capacity in Baltics. And this means that during their production times, which is, especially for solar, which is summertime, there's going to be power production that will be higher than the demand, which means that in summers, we predict that the electricity prices could be very low during these consumption periods. So this means that if you add a battery energy storage solution, you can do generation shifting, which basically means that during your highest generation peak, you store this energy in the battery, and when the electricity price is higher, you release it to the grid. So I have tried to depict this in this slide. And by this, you can avoid, let's not call them losses, but low revenues that you would have if you wouldn't have such battery systems. And this would probably also reduce the return on investment for the whole solar or wind plus battery system itself. So there's great financial benefits in using such kind of system for these projects. And one of the final applications that's more important for larger systems, but can also be used for CNI, is grid auxiliary services. And for those who know, and for those who don't, the transmission system operators must maintain the grid frequency of 50 hertz in our region, plus minus 0.2 hertz. And there might be situations when the consumption and generation is not equal. And this means, for example, if we do have consumption that is larger than the generation, then the frequency of the network decreases, and transmission system operator must inject more power into the grid to balance the consumption with the generation. And also there might be situations when there is larger generation than the consumption, and then the transmission system operator has to shut down or reduce the power of generating plants. And for these applications, the batteries can be used either as frequency continuation reserve, which is called primary reserve, or if there is a case when we have these either decreased frequency or increased frequency as a frequency restoration reserve. And there are multiple levels. You can have secondary reserve, you can have tertiary reserve, and even fourth level reserves. But these are the main functions of such kind of applications. And also, previously we talked about some different application scenarios, but by using smart control systems, which is called energy management systems, we can provide multiple different application functions into one ESS or BSS system, which means that we can, for example, reserve 50% of the capacity of the battery that we have for the usage on grid balancing applications for frequency continuation reserve or frequency restoration reserve. Then the rest 50% in the morning we can do for peak value arbitrage, where we just in the night we charge the battery when the electricity price is low and discharge the battery in the morning when the electricity price is higher. And in the day when, for example, if we have a PV plant, we can store some of the PV power in the battery and then release it in the grid later when it is more convenient and the electricity price is better. So thus there are multiple application scenarios that we can have, as well as mixed mode applications, which can probably have the best return on investment for your solution. So as we have discussed the applications of the BESS and understood what the CNI BESS solutions consist of, let's talk about a couple of important parameters that are important when considering such solutions. And first one, and probably the most obvious one, is what kind of capacity you want. And note on this point is that it's important to understand whether you need to have specific capacity that you want at the AC side, which means usable capacity, because the capacity of the battery will usually be higher than the one that you will be able to get on the system output due to efficiency of these battery management systems, battery management system modules, as well as inverters, etc. So on the AC side, you will always get less power. So these are things that you need to consider when talking about the capacity of the battery. Also, important factor, of course, is output voltage, which for CNI projects in Baltic states, we use three-phase 400-volt grid. And also, this is relevant for type A power plants with PV or any other renewable source plus BESS power, which is lower than 499 kilowatts, kilowatt power. So if you have, for example, 400 kilowatt hour battery and 150 kilowatts of solar, if you have battery which with output power of 400 kilowatts and you have PV plant with 150 kilowatts and you want to add that to the grid, it's already exceed this 499 kilowatts. So that's already a type B power plant. So this is also important factor to consider. And in this case, if it's type A plant, then inverter or power conversion system should comply with LVS and EN 50549 /1 this standard, which is low voltage standard. And if our system is more than 4.999 megawatt hours of power, then of course that's type B power plant, and we must connect this system to 6, 10, or 20 kV lines, and usually this will happen using medium voltage transformers. And in this case, we have to comply with medium voltage standard, which is 50549-2. The next parameter that's important to understand is also if it's indoor, if it's planned to be stored indoors or outdoors, because there are different solutions that are prepared for indoor use and for outdoor use. And factors here are also temperature range. And there are two temperature ranges that we are interested in, and that's one of which is operational temperature range, which means the temperature at which the battery will be actually charging or discharging, and the standby temperature range, which means the temperature at which the battery will not perform any actions, will not charge or discharge. And of course, there's also corrosion protection for outdoor solutions, and we advise to have C4 plus corrosion protection for it. One thing to note here is that whenever considering such kind of systems, or when you have requests from the clients when they want to have such kind of solutions, always request for these temperature ranges, and of course if it's indoor or outdoor, because it will greatly affect what kind of solutions we will be able to provide to them. Also, important parameter which we already touched upon previously is charge or discharge power. And this is important because there are different cell technologies with different charge and discharge rates. And of course, it's also important to match the charge and discharge power of the batteries themselves with the power conversion system / inverter, so that you can use your power most efficiently. And regarding battery charge and discharge, there is a specific parameter called C rate. And in simple terms, the C rate basically says how fast you can charge a battery. And it's usually given in terms like 2C, 1C, 0.5C, and 0.25C. And for example, 2C battery will be able to discharge its capacity in 30 minutes or 0.5 hours. So it's 1/2 of the hour. So 1C battery can discharge or charge in 1 hour, 0.5C can charge or discharge in 2 hours, and 0.25C rated battery can charge or discharge in 4 hours. And by knowing these parameters, we can also easily calculate what is the maximum output power of the battery itself if we know the battery's capacity. So for example, if we have the battery of capacity of 100 kilowatt hours, and we know that charge discharge rate is given 0.5C, then the max charge discharge power is 50 kilowatts. So we can use that to calculate this parameter. On this slide, there are a couple more parameters that are important, and from which one is cycle count. And this is actually very important. And this cycle count defines the number of full charge discharge cycles per day. So this is a parameter that your clients will specify because it will determine the battery types used, as well as it has a great effect on the warranty of the system, which is also very important for commercial clients. And to illustrate this, I will give you an example. So if the client has understood that they will have 0.8 cycles per day, which means that this system will be charged and discharged one time every day for 80% of the year, which means it will charge or discharge 292 days, for example, because there shall be days when the battery shall not do anything, or it will be on maintenance period. That's why such kind of parameter. And next, you can see that we can easily calculate this cycle count per se. So if we know that we will have these 292 days that we want this battery to be charged or discharged once we want this battery to be charged or discharged, then we just divide it by 365 and we will get this cycle count, which in this case is 0.8 cycles. And the second example is that we know that our battery will be discharged approximately 2 times each day. And this means that in total per year, there's going to be 730 charge-discharge cycles. And of course, if we divide by 365, we get 2 cycles per day. And why this is important regarding warranty? Because warranties for such kind of CNI and utility systems are given in years and in discharge cycles. And to illustrate this, here's an image from warranty terms and conditions for Huawei Luna 2000 systems. And this system has 10 years of warranty, but with certain amount of cycles depending on the discharge power of the system. So for example, for Luna 2200 kilowatt hour system with charge and discharge ratio of 0.5 C. So if we calculate this, 200 times 0.5 is 100 kilowatt of output power. We have warranty cycles. We have 5,000 warranty cycles. But if we want to, for example, have 97 kilowatt hour battery, which you can see here, and discharge it with 1C, we only have 3,200 cycles of warranty, which means that if we reach these 5,000 or 3,200 cycles, then the warranty expires, even though if the time warranty is still valid. This doesn't matter. Whichever comes first, either the cycles or the time, then the warranty expires. And on the right side, I've shown a couple of examples regarding warranty calculation. So in one case, if we have 0.8 cycles a day that we have planned our batteries to be used, or the client has planned it, and we don't want to discharge them more than 0.5 C, then we shall reach these 5,000 warranty cycles in 17.2 years, which means that we are safe, and the warranty of the battery will, of course, end in 10 years, but it will not end faster. But if we have a system with 2 cycles a day and 0.5 C of discharge and charge rate, then we shall reach these 5,000 warranty cycles in 6.8 years, which means that our warranty in this case shall end in 6.8 years. So that's why, as this cycle count has so big importance for warranty, it's crucial to request this planned cycle count from the client, so that the best solution can be found and the warranty can be adjusted accordingly. Of course, there are also other important parameters in BESS. So it's depth of discharge. We already talked about this. For lithium iron phosphate batteries, this is up to 100%. Also important how close this battery is going to be to the sea, because for the solutions that are closer than 10 kilometers, we must use air conditioning for PCS, not natural air or forced air ventilation due to humidity reasons. And also important factors are communication protocols. For CNI solutions that are up to 499 kilowatts of output power, so we don't need communication to SCADA in Latvia, to SCADA DVS, but for solutions which have output power of more than 499 kilowatts, we need, of course, communication with SCADA, so that's important. There are also other parameters that are important, but we shall not discuss them here so that we don't overload you with the information. Also, one slide regarding certifications and standards that are required. So all these solutions must conform with European Commission these regulations, EU CE certification, and of course EU EMC directive. Also, they have to comply with EU transportation directive, which is UN 38.3. Connection to the grid we already discussed. For type A, it's 505491, and for type A, and yeah, for type B power plants, it's 505492. battery modules, there are some standards that are relevant, but they are not mandatory. So those are listed here as well. But I would like to point out some safety standards that are important if we talk from the safety perspective. And this is UL 9540 and UL 9540A. Which basically are test results for these battery systems regarding their flammability and their thermal runaway. And these tests, these standards basically provide a test result which shows how if these batteries will have thermal runaways and if they will cause fire and how severe it can be. So these are important things to have for your systems. And of course, we have this fire safety standard NFPA 855, which is also important. Then there's ingress protection, IP protection, IP class, and also becoming more important is cybersecurity requirements. They are mostly for utility scale projects, but for probably they are going to be used for CNI as well. And if we talk about standards, why they are important. So on this slide, I wanted to show two examples of what happens when you don't follow standards or there's an issue with the batteries itself. So on the left, you can see not TNI, but that's already utility scale project in Australia, where one of the battery containers caught on fire, and to take out this fire, it took 92 hours, and it took 30 fire trucks and 150 firefighters. So we want to have these standards for these batteries because they are such kind of represents the quality and safety and shows that these batteries, there's a lower chance of these batteries to caught on fire, like in this scenario. And also on the right, we can see a house or what it looks like after an explosion of battery system. And here, if we see the battery was only 30 kilowatt hours, but it was cheap battery from Alibaba or AliExpress, and these batteries did not have any safety standards, and due to these reasons, this battery one day decided to blow up and take half of the home with it. So that's why these safety standards are very important, and we want to encourage you not to purchase third-party, unknown brand, unknown quality batteries from especially Chinese manufacturers, which don't have these safety standards, because you're risking with not only your house or your finances, but also with your life as well. So as we are running out of time, I shall now try to speak a little bit faster and skip some things. In this slide, in order to calculate what kind of battery would you require for your CNI solution, there are a couple of tools available. So for example, there's Huawei return on investment tool, which you can put in a lot of parameters regarding your system, and then it can calculate what kind of batteries you will need and other things such as return on investment, etc. So here are image of this tool where you can add in information like your annual energy consumption, workday module, consumption module, and you can you can add these values really like specifically so that you can get the best and most precise calculation, which will give you the solution that you need. And at the end, the result is a report which will provide you with the battery capacity that you will need, as well as some other financial parameters. Note that this is all just a Huawei solution, and it will provide as a solutions only Huawei batteries, but you can use it just to calculate the battery capacity and then choose battery from different manufacturer as well. And one of the most important, interesting slides is our solutions. And on CNI, we have indoor and outdoor solutions available. And for indoor use, we have solution from PylonTech, which is battery producer, and a Solinteg, which is hybrid inverter manufacturer. So PylonTech is quite already established manufacturer, but Solinteg is quite new, but they have really good hybrid inverters, which you can use in CNI applications. And for example, with such kind of systems, you can create a solution with capacities up to 164 kilowatt hours. You can multiply this by how many these battery stacks or racks you want to have, plus Solinteg inverter, hybrid inverter, that can have output power starting from 25 up to 500 kilowatts. So this is really good, and I would say cost-effective solution, which allows you to easily integrate PV into it. This solution has backup functionality, also UPS level switching, which means that if we have a power outage, then all the loads connected to backup output will not lose power because switching time is less than 1 hertz in frequency. And also this solution provides unbalanced output feature, which is also important for our region. It can have up to 110% of unbalanced output, which is even more valuable for us, as we tend to have multiple loads on our three-phase system with different power requirements, and this unbalanced feature allows us to have different output powers per phase. So this is one of our indoor solutions that we provide. Also for PylonTech, there is outdoor solution, which you can see here on the image on the left. The solution is 100 kilowatt hours, but we are working together with PylonTech to creating a solution up to 300 kilowatt hours that would be more suited for, that would be specifically suited for our climate and specifically suited for our applications. And also we do provide Huawei solutions. So I would say most of you are well aware of these. So Huawei provides their outdoor containers, which have capacities of 200, 161, 129 kilowatt hours. Of course, you can stack multiple of these containers together, and you can have systems also up to megawatt hours of capacity. And we also collaborate with BYD. So BYD also have their own CNI solutions. So this particular solution is 266 kilowatt hour outdoor container. We also cooperate with Narada, and here's an example of their provided commercial storage solution, which is 211 kilowatt hours of capacity. We also, as we are part of BayWa RE, we do have access to the whole assortment of BayWa RE batteries. So we also have access to batteries from brands like Intellion, Varta, and SMA. So by this, I just wanted to say that if you have specific need for your systems or specific manufacturers that you would like to have, so we have access to them. And as we are really running out of time, I'm just gonna shortly say that we are working together with the largest battery manufacturers, and we also, BayWa RE, has an experience in commissioning large battery projects. Here you can see in total of 17.63 megawatt hours. And we also have upcoming projects in 2024 as well. And here you can see some of the projects. These are utility scale projects, but these can also be used as reference for us. And yes.
If you have any questions,
finally
you are very welcome to ask Michal or Kaspars.
Yeah. One thing to note from my side is that we have created a requirement sheet that we shall share with you regarding battery solutions, where we state which kind of parameters are required for us, which you can fill yourselves or you can give to the clients. So they fill them and send them to us so that we can use it as a reference to provide you with the best solution for CNI storage.
Any questions?
Yeah. Any questions?
Yanis, go ahead. Yanis, you can ask question. Yanis is asking question. Yanis,
yes, Jans, you are muted. Maybe you can unmute yourself.
Thank you very much for nice presentation. Yeah, can you hear me? Yeah.
Yes.
Yeah. Can you say some words about some residential battery solution? What you can offer for?
This was not today topic.
Yeah, but, just short. So it's
short.
It's BYD. All HVM, HVS is low voltage versions as well. Then there's Pylantec as well. So BYD would be more premium. Pylantec would be more cost efficient. All Huawei batteries. What else? Yeah, also GoodWe Lynx batteries. And we have access to other batteries provided in BayWa RE group. So if you have something specific, just ask and we will be able to get it.
Tesla Powerwall 3 also.
TIGO.
Pylantec will be available, yeah?
Yeah, will be in stock. Yes, yeah. Pylantec will be in stock.
Yes.
Thank you. Thank you very much.
Any questions about TIGO to Michal? We have 36 guests. If no questions, I would like to say thank you for your presentations, Kaspars. Thank you, Michal. And I hope we will get some TIGO orders, and wish you good day today.
Maybe final words from my side. Thank you for the presentation, Michal. Thank you myself. And I just wanted to remind you that we have sent out a form regarding inverter and battery products that you can fill. So please fill this form, answer these questions, because it will allow us to have the portfolio in 2024 that's more suited to your needs. So please fill this form.
And if may I add, I said on very beginning, we will soon will change more aggressive price strategy. What you see now and what you will see later, it will be completely different. And shop will be B2B closed for registered customers. Yes. That's all. Thank you, everyone, and
Yeah.
see you today this year and see you in good business together.
Yeah. Thank you,
Also,
everybody.
thank you, everybody.
Yeah.
Thank
bye.
you. Thank you. Bye.
Thank you. Bye.
Bye.